Weaving, one of the oldest technologies practiced by humans, is the process of fabric manufacturing by interlacing two sets of yarn called warp and weft. The basic material needed for weaving are two sets of threads. The first set is called the warp, two rows stretched the lengthwise. The second set is called the weft, and it goes back and forth between warp. The threads are now becoming a piece of fabric. To keep them from unraveling, a reed pushes the threads together. Weaving of yarns into a fabric is performed on a weaving machine, which has also been called a loom. In the weaving, many developed machines are using in the textile industries. For example, air jet loom, rapier loom, water jet loom, jacquard loom, etc. The way the warp and filling threads interlace with each other is called the weave. The majority of woven products are created with one of three basic weaves: plain weave, satin weave, and twill weave. In this episode, we will explain the textile weaving process step by step. Yarn preparation. Yarn collects from the spinning industry, but it needs to prepare a suitable count and package. Winding. Winding requires for preparing suitable yarn package. We know that in the weaving process, two sets of yarn is used: warp and weft yarn. Warp yarn wind into a cone package, but weft yarn wind into preen package for conventional loom and cone package for a modern loom. Warping. Warping is intended to prepare the beam of the weaver to be installed on the weaving machine. Warping performs the following operations: create out of a limited number of warp threads. A warp composed of any number of threads with the desired length. Arrangement of the above-mentioned threads according to the desired sequence. The industrial warping process can be accomplished. Sectional warping. Conical drum or indirect warping. Beam warping or direct warping. Sizing. Sizing is the implementation of the adhesive protective layer before weaving in the warp threads. Warp yarns can resist the complex stresses they are subjected in the weaving machine. Weaver beam preparation. For long runs of gray fabrics, beam warping is used. As intermediate stage, warper beams are produced that can contain up to 1000 to 1100 ends. Then 6 to 12 warper beam threads are merged at the slashing stage and wound on a weaver beam. Drawing. Drawing is done to pull the threads of the warp through the heeled wire's eye. Denting. Denting signifies drawing the warp thread through the dent as reed plan requires, and this more reliably specifies the fabric width and ends per inches. Looming. At the start of the new warp, the tail end of the warp from the exhausted weaver beam is attached. It is called tying in. Therefore, the drawing mechanism may be excluded if each end of the new beam is attached to its consequent end on the old beam. All knots are pulled through the drop wires, heddles, and reeds after the tying in process. The loom is ready for use now. Weaving. Finally, weaving is started, others process will be followed for delivery. Weaving can be summarized as a repetition of these three actions, also called the primary motions of the loom. Shading, picking, beating up or battening. Shading, where the warp threads are separated by raising or lowering held frames to form a clear space where the pick can pass. peaking, where the weft or peak is propelled across the loom by hand, an air jet, a rapier, or a shuttle. Beating up or battening, where the weft is pushed up against the frill of the cloth by the reed. The warp is divided into two overlapping groups or lines that run into planes, one above another, so the shuttle can be passed between them in a straight motion. Then the upper group is lowered by the loom mechanism, and the lower group is raised, allowing the shuttle to pass in the opposite direction, also in a straight motion. Repeating these actions forms a fabric mesh, but without beating up. The final distance between the adjacent wefts would be irregular and far too large. The secondary motions of the loom are the let-off motion and take-up motion. Let-off motion, where the warp is let off the warp beam at a regulated speed to make the filling even and of the required design. Take-up motion takes up the woven fabric in a regulated manner so that the density of filling is maintained. The tertiary motions of the loom are the stop motions, to stop the loom in the event of a thread break. The two main stop motions are the warp stop motion and weft stop motion.